A single tablespoon of water sucked into your running engine can cause instant, catastrophic mechanical destruction costing over $8,000 to repair. Water is liquid and cannot be compressed like air, meaning a momentary lapse in judgment while crossing a puddle can snap steel connecting rods in milliseconds. Most drivers assume their factory air intake sits safely high above the pavement, but modern aerodynamic designs place intake ducts shockingly close to the ground. By the time your dashboard lights up with warning signals, the internal damage is already permanent and irreversible. In this video, we are breaking down 5 silent rain driving mistakes that destroy engines, warp brakes, and ruin electronics. By the end, you will know the exact water depth threshold that turns a routine wet commute into a total mechanical write-off. Before we examine how water enters your combustion chamber, you need to understand why wet weather creates a perfect storm for silent component failure. We will analyze why braking hard right after crossing standing water warps cast iron rotors in seconds, and how a high-speed splash through a tiny puddle can flood a $3,000 electronic control unit. You will also see why modern turbocharged engines are twice as vulnerable to wet air starvation as older naturally aspirated vehicles. Most importantly, we will reveal the one innocent habit at flooded traffic lights that secretly forces water straight back into your exhaust system and destroys your catalytic converter. To protect your car this season, let us examine these 5 destructive habits one by one. The first and most catastrophic mistake is driving too fast through standing water, even when it appears shallow on the surface. When your tires displace water at 40 miles per hour, they create a dense high-pressure bow wave directly in front of your front bumper. This bow wave forces water straight into the lower radiator grille where modern air intake ducts are strategically routed for cooler air. Gasoline and diesel engines rely on compressing a volatile mixture of air and fuel by a ratio of 10:1 or higher. The exact instant liquid water enters that vacuum, your engine encounters a physical wall known as hydraulic lock. When hydrolock occurs inside a running cylinder, the immense kinetic energy of your spinning crankshaft and heavy flywheel does not simply stop instantly. It violently forces the piston upward against non-compressible water, bending forged steel connecting rods like thin wire. In severe high RPM cases, the bent rod fractures entirely and punches a fist-sized hole straight through the side of the aluminum engine block. You are left with an unrepairable engine block and an oil slick washing down the storm drain. The worst mistake drivers make next is attempting to restart the key, which turns a single bent rod into total internal engine fragmentation. The second hidden mechanical danger occurs when you drive through deep standing water and immediately apply heavy braking pressure. During normal highway or city driving, your iron brake rotors regularly operate at temperatures ranging from 300 to 600 degrees Fahrenheit. Submerging or thoroughly soaking a glowing cast iron rotor in cool rainwater triggers severe, rapid thermal shock. The outer surface of the hot iron contracts almost instantaneously while the inner metal core remains expanded. This rapid microscopic shift in thermal expansion distorts the flat friction surface of the brake rotor, creating permanent surface warping and structural stress rises. The very next time you step on the pedal, you will feel a violent shudder through the steering wheel and brake pedal assembly. Over time, this uneven rotor surface destroys your brake pads unevenly and places excessive wear on wheel bearings and suspension bushings. Furthermore, rapid cooling causes microfractures in the friction material of your brake pads, reducing wet stopping distance by up to 30%. The third mistake happens on open highways before you even hit a standing puddle, tailgating heavy traffic and semi-trucks during a downpour. Large commercial tires displace hundreds of gallons of water per minute, misting a thick aerosol slurry of road grime, oil residue, and fine water droplets into the air. Your engine continuously pulls this high-density moisture fog into the intake box over miles of highway travel. Standard paper air filters absorb this ambient moisture like a sponge, causing the cellulose fibers to swell and restrict critical airflow. As the paper filter becomes completely saturated with oily water, the structural integrity of the pleats fails under the strong suction vacuum created by your engine. Wet paper fibers tear open, allowing unfiltered water spray and road dirt to bypass the filter entirely and hit the mass airflow sensor. This sensor uses an extremely delicate heated platinum wire to calculate precise fuel delivery, and liquid droplets cause instant sensor contamination. Your engine's computer receives wildly inaccurate air mass signals, leading to rich fuel misfires, severe hesitation, and eventual catalytic converter flooding. The fourth mistake involves blasting through standing puddles at high speeds under the assumption that your plastic belly pan protects the undercarriage. Modern vehicles are packed with dozens of sensitive electronic sensors, steering racks, and transmission wiring harnesses mounted along the lower frame. High-velocity water displaced by your tires hits these flimsy plastic splash guards with enough force to tear them away completely. The resulting high-pressure water jet washes directly over critical electrical connectors. Once high-pressure water forces its way past the weather-sealed rubber gaskets on electronic wiring harnesses, trapped moisture begins corroding copper pin terminals immediately. Green copper oxide builds up between adjacent pins, creating short circuits that confuse wheel speed sensors and automatic transmission shift solenoids. Even worse, water invading the alternator housing carries road salt and debris that grounds out internal copper windings. A single aggressive splash can trigger thousands of dollars in erratic electrical failures that take technicians weeks to trace. The fifth mistake occurs when idling or crawling through submerged roads while stuck in heavy traffic on flooded streets. Exhaust gas pressure at low idle speeds is remarkably weak, especially on modern small displacement engines designed for fuel efficiency. If water levels rise high enough to cover the tailpipe opening while your engine idles slowly or stalls, water pressure can overcome exhaust flow and enter the tailpipe. Cold water traveling backward down the hot exhaust pipe creates immediate thermal shock inside the catalytic converter. Cold water contacting a 1000-degree ceramic catalytic converter substrate causes the internal honeycomb matrix to shatter instantly into fine powder. This pulverized ceramic material creates a dense blockage in the exhaust line, preventing the engine from breathing or restarting. In severe scenarios, the vacuum created when a stalled engine cools down can actually pull sharp ceramic particles backward through open exhaust valves directly into the engine cylinders. Once inside, those abrasive ceramic fragments score the cylinder walls, destroy piston rings, and ruin engine compression permanently. Beyond direct engine and electrical damage, high-speed rain driving subjects your entire mechanical drivetrain to violent rotational shock loads. When a drive wheel rapidly loses traction on standing water and then suddenly re-engages solid pavement at highway speeds, extreme torque spikes ripple through the driveline. These sudden traction surges put immense stress on constant velocity joints, differential gears, and transmission clutch packs. The sudden shift from zero resistance to full traction forces internal components to absorb thousands of pound-feet of shock load in a fraction of a second. Navigating heavy rain safely requires understanding how water interacts with your car's physical intake geometry and ground clearance. Always scan the roadway far ahead and use curb lines or surrounding vehicle tires to accurately gauge water depth before proceeding. If standing water reaches the center cap of your wheels or covers the bottom door seals, turn around immediately. If crossing shallow water is unavoidable, drop your speed to a slow walking pace before entering to keep a destructive bow wave from building in front of your front bumper. If your vehicle ever stalls unexpectedly while crossing a flooded section of road, resist the natural urge to turn the key and attempt to restart. Cranking an engine that has ingested water guarantees bent connecting rods, cracked pistons, and a destroyed block. Leave the ignition off, push or tow the vehicle to dry ground, and pull the air filter box open to inspect for standing water. Removing the spark plugs or fuel injectors before manually turning the crankshaft safely clears liquid from the cylinders without exerting fatal mechanical pressure on internal engine parts. Adopting simple post-rain inspection habits will keep your vehicle reliable and prevent hidden water damage from developing into costly repair bills over time. Always inspect your engine's air filter element after driving through torrential downpours or deep puddles to confirm it remains completely dry. Inspect your brake discs for surface flash rust or unusual pedal pulsation after heavy storm events. Taking 5 minutes to check these vulnerable components ensures a simple rainy day commute never turns into a multi-$1,000 mechanical disaster.